So this was the first one. Hopefully you can see that there. And it's pretty great looking. The printer we worked with is local, and we were really able to do like kind of a. It's really good. Like it just looks amazing. Um, the colors are like really nice. It's hard to show it on camera. This camera is also a bit desaturated, but it's just such high print quality on this thing. They did an amazing job. It's one of the best looking graphic novels we have on the shelf, and that's all down to the print, right? I mean, Anna does great artwork, obviously, but like when you're talking about what the difference is between what it looks like on the screen and what it looks like printed, it's just how good are those printers. And they were just great working with the pre-press and everything. They like had such good people, and we went through and like corrected all this stuff in terms of how to ink it properly. So it just ended up being like a really great time. So we're excited about doing book 2. And we're hoping the Kickstarter works out, obviously. But if you want to check it out, the link should be down below. Oh, the Jeff and Casey show. Okay, yeah, we can talk about that. Sure. Actually, let me put the Kickstarter link in here. People who want to check out the book. So the Jeff and Casey show has 2 problems right now. Problem number 1 is just that Jeff kind of had like so he used to live in Seattle, right? So we were in the same city all the time. So it's pretty easy to record. He sort of now splits his time. He lives part of the time in California, and part of the time back here. And so it's kind of like hard to sync up schedules because, when he's back here, only part of the time he's obviously doing important stuff and all that. And, especially now with the fact that Rad got bought by Epic and all that stuff, there's just a lot of like difficulty in scheduling. So that's one thing. The other thing was coronavirus, right? So people were quarantining and staying at home a lot and all that sort of stuff. So, should we record more episodes, Jeff and Casey? So yes, both of us are vaccinated. Both of us try to be pretty careful, but I don't know. Jeff is in contact with more people, so I don't know. We could try to be safe about it, but you get me and him in yelling at the top of our lungs like we do at the podcast in the same room together. If either of us caught coronavirus, we're accidentally going to give it to the other person. There's no way around that. I mean, I suppose we could do the podcast with masks on, but it's definitely an issue. So, we'll see. We'll get back to it soon, and coronavirus hopefully will become less of an issue anyway as treatments. They're working on good treatments and stuff for it, and I think they'll probably have better treatments coming up, and so at some point we could just say like, hey, it doesn't matter, let's just do it. But we still have that scheduling problem. So when Jeff's schedule opens up maybe a little bit more, we'll try to do it for sure. Yeah. Have you looked at Twitch's code? I have not. I assume you're referring to they had like a hack or something. I know that they did because they sent out an email. I haven't really read the news on it. I think I saw something about it, but I know that they did because in order to stream tonight, I had to reset my stream key because they sent out an email where they were like, hey, you guys got to reset all your stream keys. And I'm like, okay. So I haven't looked at anything from the leak. I don't know that I would want to ever look at Twitch's code because I'm sure it's pretty special. So I don't want to see that. It'd probably give me nightmares. And I guess I'm not super concerned about it necessarily because, I mean, we're not a high profile streamer. We don't, I'm not afraid someone's gonna go find out how much the Handmade Hero stream makes a year, because it's not very much, right? I can see why maybe like people having that information compromised could be kind of a problem, right? If you were trying to keep that information secret, but we're not. I mean, I think Twitch pays us something like $1,000 a month. So that's information I would just give out. So I don't really have too many concerns about the leak, other than kind of one of the obvious things, which is that, like, man, like, why do we bother with all this stuff? There's like 2-factor authentication and all this crap. Like, come on, man. Like, I mean, no one's ever hacked one of my accounts. And at this rate, I don't know why they would, because it seems like it's easier, rather than trying to hack one of my accounts. They're not even going to bother. Just hack the server, right? Why would you bother trying to come hack Casey Muratori, right, when you could just hack Twitch, So it's getting kind of ridiculous, because practicing your own kind of cybersecurity is now becoming kind of a moot point, because at some point all of the places that you log into are all hacked. So it's like, okay, great. Yeah, they can't compromise my account specifically, but it doesn't matter because they compromised the whole server. So they effectively got my account anyway, right? So it's just embarrassing. It's just embarrassing. Yeah, I mean, and Strange Zach, exactly. Like, I mean, a low profile streamer such as myself, or anything else, like, like Sony was hacked too a while back, right? And you think about the average PlayStation user, right? I mean, how much energy am I going to dedicate into securing my PlayStation account, right? I mean, who cares? Yeah, good. You could go on there and file the refund for Cyberpunk 2077 for me, right? It just doesn't make a lot of sense, because it's like these companies get hacked, and your account is comparably is meaningless, right? Your account's nothing. No one cares what's in that thing. And so, like, why do we take all these steps? Why do we have all these passwords? Like, what is the point of this? They hack the whole server. What was the point of any of this stuff? Why am I sitting there trying to enter a stupid password on like a bad gamepad keyboard? Who is that protecting when the hackers just hack the entire system, right? It's like, you would think by now some of these companies would actually have some reasonable security, but they definitely don't, because every week it's another thing like this, right? Like, it's another thing every time, and it's just shows no sign of letting up. So Haas and Judy asks, I think you are working on a web server project. What do you use for data persistence? Just files, SQLite, or your own version of file system in a single file? None of those, although it is closest to the last one. At the moment, I am just using raw writing. So basically, you just write to a raw device directly, right? So like Linux, when you want to access like a file handle of a device, right, you can just raw write to it if you want to. And I don't know that that's what we'll actually ship with. I'm gonna have to decide this stuff a little bit soon, because it's getting close to the time when we want to actually put something up. And I kind of develop like a hybrid on Windows and Linux. And I don't actually know to what extent some of this stuff works well on Linux or not. That's the only really tricky spot for me of doing the server programming, is that you're not gonna ship a Windows server, because like who's gonna pay Microsoft $200 per server? And you could have 10, 20 servers depending on how you scale up your system, right? Who's gonna pay Microsoft for that crap when it doesn't do anything, right? So the fact that I'm a game developer means I'm used to programming on Windows, and it's a little bit of a handicap, because it's like, well, I just don't know all the esoterica from Linux the way I kind of do on Windows. On Windows, if I want to do something weird, I kind of know. Like, I know how it goes. I know some of the vagaries of the operating system, and it makes it a lot easier to do kind of weird stuff, right? Whereas on Linux, I'm like, okay, I can go read the documentation and it says this will work, and then maybe I can test it on my machine, but then like I go to deploy it on whatever CentOS nonsense or something is on the server on some server farm, it doesn't work or whatever. So there's kind of this whole thing, and that part is one of the big things that just isn't done yet as far as getting our server stuff deployed, is figuring out how that stuff is really going to work. And the reason I say that is because for us, like pricing and what server farms to use and that sort of stuff has been like very challenging. You know what I'm saying? I thought we were going to be able to use like there's a couple places I was like, oh, these are pretty low cost places we can get servers at, and they have things like 10 gigabit per second unmetered, which is kind of what I wanted. But like you look at those and they don't use ECC RAM, so you're like, okay, that's probably not great. And so you kind of go around and around. And you're like, okay, this place looks pretty good, but are they too expensive? No, all right, I guess they're okay. And how's this going to deploy? So I don't know. There's a lot of ways you can go with this stuff, and it's again, the problem there is mostly just that I'm a game programmer. The web server side of things is not hard for me from a programming standpoint because all of the things that are involved I've done before, but the platform stuff is not. And so it's been a bit of a struggle platform-wise, figure out like how are we going to get these servers, where are they going to be, and who's going to host them, and how much are they going to cost? What is the realistic actual like performance of these data center things? Like a perfect example would be if I'd done this a bunch of times before where I'd like deployed, custom server infrastructures before, I would just know a few things. Like one of the things I would know is a few data centers I'd worked with before, what actual throughput do you get? Right? Like if you buy a 10 gigabit per second uplink from such and such data center, what do you actually get, right? Because you see all these things like, oh, this is 10 gigabit per second guaranteed, or this is 5 gigabit per second guaranteed, or whatever. Yeah, I don't know what they actually mean by that, right? It's the kind of thing that people fudge the numbers about, or it's not exactly entirely above board, or those sorts of things. So I do think that, like, to a certain extent, there's going to be some growing pains. The end of this year is going to be pretty rough for me, I think, because as I try to put this stuff online and actually get it battle hardened, I'm sure I'm going to have a lot of issues with things don't go the way I thought they would, because what, is said in documentation or on people's websites or whatever isn't really what happens, right? And those are the kinds of things that once you've been around the block a few times, you know, but until then you haven't. So StrangeX said he had a good experience with OVH 10 GB lines. So that's great information. Thank you for saying that. Like I'll check that out. I know who you're talking about. Hearing stuff like that's just useful for me, right? Like hearing that people did such and such and had a bad experience or had a good experience. It's just useful, right? One of the other things I consider doing is just building our own machines and mailing them to data centers, right? But I just felt like that might be too much variability there and too much back and forth. Oh, which power supply do you need to use for this data center? And oh, it got dropped in shipping and now the machine doesn't work. And so I just, there's so many ways you can deploy a server architecture nowadays. It's like writing the server architecture is very difficult, certainly, but it's the part that I understand, right? Getting the actual hardware, is like a new part for me because it's just not something I've done. And so I'm not looking forward to that, but it has to get done, and it has to get done relatively soon. So, I'll have more to say about that later. What exactly we use in terms of storing files may have to change slightly depending on the circumstance. But just raw write is basically what I wanted to do, because the reason for that is I just don't. So when you're talking about something like a server, the operating system basically gives you almost zero benefit. Like ideally for something like a web server, there would be no operating system. And to a certain extent, you could do that, right? You could write something really honestly bare metal. But the investment in figuring out how to get all the driver stuff that you need set up, like in your own custom code and all that stuff, that's a pretty dangerous route to go down, right? It's not like the old days when computers were more uniform, so you kind of knew, like, if we're deploying, if if we're deploying an Amiga 500, then we don't need an operating system because we could just implement the individual hardware things we need right on there and it works, right? So, at least for this first round of deployment, we're going to be sitting on top of Linux kernel, but nothing else. And I don't really want a file system. It doesn't do anything for us. It just gets in the way. We don't want metadata. We don't want multiple files. We just want the server to be able to store the data that it needs. It knows where the data is and it knows how it's organized, so it doesn't want anything other than just a raw ability to like read and write sectors. Ideally, knowing how big the optimal sector size is even would be a plus for us because we can't take advantage of it. So like the closer we can get to raw write, the better. But I didn't want to go all the way to like we're writing the disk driver because I just felt like that was way too risky and way too big of a time investment. So we're up one for that, but we'll go down as far as we can otherwise. Like we don't really want anything else running on the system. As far as I'm concerned, everything else is just a security headache and a maintenance headache for me, right? Anything else that runs on there is just something I don't really understand. I don't know Linux file systems very well, right? So I would just have as little as possible. As close as possible, just booting directly into our code and then just having the hardware do exactly what my code says is what I would prefer because that's going to be the most secure because there's not other things running that people can attack, right? And it's also just going to be the least maintenance headache because the less code that's running, the less I have to worry about someone else's code like breaking or whatever, right? So by raw writes, what I mean is, at least in certain circumstances, depending on how things are set up, you don't actually need the operating system to do any kind of like brokering of where or what you're writing. So normally what happens, right? When there's like two levels of file system. Maybe we could go to the lightboard for this. Actually, I'll go to the lightboard for this. Let me just feel this one other question that was here. Someone said not a game dev here, but wanted to let you know that your approach to software development took me out of a burnout. Short story long. Arigato gozaimasu. Dou itashimashite. Very glad to hear that. Obviously. So let me go ahead and just take a second to draw it out, because I think I can explain this a little bit better with a diagram. If this is something you're actually interested in, it's not a terribly difficult concept, so I should be able to just say here's roughly what I mean, and hopefully that'll be a lot clearer than me just kind of saying stuff here, if that makes sense. So what happens, right? If you take a look at what's going on in a typical scenario where you're not really trying to take control of the system, where you're not trying to be sort of down at a lower level, you typically have like a tiered sort of for every kind of a file write that you do, you have like a tiered waterfall kind of a thing going on. So maybe somebody calls like fwrite up here at the top level, and this is in your application. So like your application is got some call that's doing an fwrite, and that fwrite, it has a file handle in it, and that file handle is really just something that is going through like a library, probably, right? I mean, at least in the case of fwrite. So there's a file handle in here. And the file handle is like tracking a bunch of information. It's going to keep like a buffer. So if you fwrite something and it's small, it'll like coalesce it in a buffer, right? So this file handle has like a buffer associated with it probably. And so whatever you write is going to go into this buffer. Eventually, it's going to decide to flush that buffer. So when that buffer fills up, or when you close the stream, or when you flush the stream, or whatever else the library, like whatever the library wants to do, when this buffer is ready, and just to make this even more explicit, maybe I can draw it like this. So there's a buffer and it's filling up. You ask to fwrite this piece of information, and it puts it into this buffer, right? So you actually had this piece. You put it down into this buffer. Now the buffer has this piece. That's going to then thunk through to like a lower level call, like a syscall on the operating system or something, that's actually designed to write some data. And there's a couple different ones for this. But you could think of it this way: as what you probably have is you have the OS here, and this is a syscall, like on Linux. So what happens is this buffer, now there's effectively an interrupt happens that transitions to the OS. Again, this is very OS dependent, but on something like Linux, you're going to have a syscall occur. So it's not really an interrupt. That's the wrong word for it. A syscall occurs, which is an actual instruction, and the operating system basically wakes up and takes back control. Right. So these are happening at a higher level. This right here is all happening in some higher level ring. Right. So this is at some higher level ring in the processor. This is now going to happen in like ring 0 or something. Right. So the syscall, there's a privilege escalation when you do this, and the syscall wakes up and it's like, oh, OK, this person wants to write this buffer. So this buffer is now coming down to the syscall. The problem is, the syscall is really just there to accept the buffer from you and actually just put it in another buffer, usually, right? So what it's usually going to do is it's going to say, okay, I've got a disk cache, right, that's like backing what I write stuff, and who knows how big that is, but he told me what the file handle that was open was, because this file handle for the library had probably another file handle, like a file index, right? Like, 0, 1, 2, 3, 4, whatever, that corresponds to the OS. So the OS got that, and it got the buffer, and it's like, okay, he wants to use this handle, this index, which I know which one that was, and he wants to do this buffer. So what actual file is that? Let's take a look at what I'm doing cache-wise with files, and let me find, like, the cache location, right? And that has its own buffer. Because remember, all disk I/O on modern operating systems goes usually through some kind of a cache. You know what I'm saying? So typically what goes on is you don't actually write any data yet. Your buffer goes into some slot in the cache, right? Where it's like, this is part of a larger piece. Like, I don't know how big this is. I haven't looked at the Linux kernel in forever. So, maybe there's a 256K chunk, and we only read and write out those 256K chunks typically or something. I don't know. Maybe it's only 4K. Who knows what it is? You can go look that up. But point being, they're going to put your buffer into a piece of that cache, but it's just going to sit there. They're not necessarily going to write it. Maybe they're going to assemble some other writes first. Maybe they need to read out like what was in the other parts of the chunk into the cache and assemble this part because it overhangs part of the, like, you're like in the middle of that somewhere. Who knows, right? It could be doing anything. Again, if you don't actually go down and look at what the OS code is doing, you have no idea. It could do all sorts of things here, right? So this is going to happen. And even that, of course, is not actually the end of it, right? Because this is just like some disk, subsystem, right? But there's still going to be like one more level like below this one, which is like the actual hardware part, right? And this, who knows how this works? Like we have no idea, right? Because it could be who knows what kind of driver you've got, who knows what kind of storage subsystem you've got. But at some point, right, there's going to be a hardware layer down here, and there's the actual drive. Right? So we've got a drive here, and it's got some I/O system, right? And this could be anything. It could be the PCI bus in the case of like an NVMe. It could be like a SATA cable, like right in the case of an SSD drive. Like who knows? There's some I/O and it has to go from here to here somehow, right? So what's going to happen is eventually this buffer is going to go into some kind of a driver layer, right? And that driver layer is going to be responsible. This probably was locked in physical memory so that whatever the driver is can like communicate the physical memory across this I/O channel, right? So this was probably locked in physical memory somewhere. It's going to like sit there for a little while and some driver is going to do something to like push it out to the drive eventually, and it goes into some chunk. Like this 256K chunk like maps into there, right? And if you think about all of this stuff that has to happen, and I'm like, that's just like the broadest possible overview, right? Like what I'm talking about here is like just the basic overview. So really high level, right? If you look at all that stuff that's happening, it's just a tremendous waste of everyone's time if you actually could have just done this yourself, right? So if instead of calling some function that just said, I got this little piece, assemble it into a buffer so you can pass it to a buffer so you can pass it to a driver so the driver can send it over the PCI bus to a drive or something, right? Instead of doing all that, what we would rather do is just we find out what the native page size is for this drive and just give the operating system direct calls. It's like, I'm going to lock some memory in physical memory for you. I'm going to leave it there until I see this write complete. So I'm just going to put the whole thing you need to write. You don't need to read anything. I'm going to put the whole chunk that you're going to send as an entire chunk over to the drive so that there's no middleman, right? The driver can literally just take this directly without all these copies of copies of copies to get something down to where it needs to go, right? And incidentally, this exact same procedure is actually not that different from what happens with a network card. It's a little bit easier in one sense in that there's not that sort of random placement problem of buffers onto places on the drive. But it's very similar in that if you don't use something like registered I/O or stuff like that, you're asking the OS has to like copy it into places where it can be reached by the actual NIC that's trying to grab it out and all these other sorts of things, right? So the idea behind all of this was like kind of like convenience and making things look like an old 1970s computer that was like streaming out data, but really it's not good, right? Like you don't want any of this. And so what you tend to do nowadays, if you actually care about this sort of stuff, which, to be fair, web stuff doesn't tend to. A lot of web stuff is just like, let's have a Python interpreter running on top of a C runtime library, running on top of the OS, running on top of the driver, right? Like, so, you wouldn't be alone if you just call F-write. Like tons of people are doing that. That's totally standard in the web world. But if you actually care about high performance server stuff, which some people in the web world do, right? Some people get paid a lot of money, I would assume, at places like, Google or something to take and try to, speed up the like super crappy, all the crap that sits on top, try to speed up that bottom part. They would probably care about this sort of stuff. But you'll see things like on Windows, you have like registered I/O, and you have some other things like there are custom APIs for it. But you also have on Linux, there's a thing that's really good. It's called IOU ring. I don't know if you've ever seen this. This is what I used for the Linux layer. And basically what IOU ring is it's a way of kind of getting rid of all of that process. And it's a way of just writing and saying, look, I don't want to issue syscalls. I don't want to do any of that stuff. All I'm going to do is just get some locked memory. I should talk about what the locked memory stuff is. Maybe we can do that if anyone has any questions. But I'm going to get some memory that's visible to me and the kernel and the drivers and whatever, right? And all I'm going to do is just write the stuff I need into that memory. And I'm going to trust that the kernel will look at a little ring buffer that tells it what I want to do and just do it. So we're like two separate threads running in parallel. So what happens is you have like, your app thread, and you could have more than one app thread, obviously, but, at least one app thread, and you have a kernel thread, and they're running in parallel. And what'll happen is the app thread will it'll like prep some buffers, right? So it'll like go, okay, I got to put some stuff I want to write out in here. When it's ready, right, it'll just like issue a write to memory, and the kernel thread is just looking at that memory area, right? If this thread was like asleep, then it is still sort of a syscall. You have to do like a call that checks, and if the thread was asleep, it'll like wake it up or whatever, right? But if this thread was busy, so let's say this was busy like processing the last part, so the kernel thread is like processing some other write you were doing, like getting that ready and handing it off to a driver or whatever. If you write into the memory, into the ring buffer, before it finishes, it will just look here. It'll like go, okay, I'm done with the last thing I did. Let me look, and it'll find the next thing to do, and it'll just start doing it. So it'll start processing the next one, right? So this one that you prepped, it will process here, and of course here it was processing something you wrote before. And so you can create really high bandwidth, low overhead channels between the kernel and you that don't require these syscalls and this buffering. So this is more what I'm talking about. The raw write part of it, all I meant by that was not going through any file system stuff. So no file system layer at all. You just write crap to the disk, and you pull crap back from the disk as close as possible as you can get to that. And again, the reason for that is just to avoid the overhead of going through a file system layer, because if you're your own web server, what do you need a file system for, right? It's not like multiple people are like using this machine, and you need, someone to be able to talk about this JPEG that, they put there. It's like, you're the only person running. You're the server who's serving everything. So there's no reason why you would have to go through some intermediary to know what like the name of a file is, or where it is, or how big it is, because you're the only one who wrote anything, and you're the only one who reads anything. So just keep that table yourself, and you don't have to go through ext4 or, ReFS or ButterFS nowadays on Linux, I guess, probably. So between IOU ring and trying as much as possible, depending on the circumstance, to just use raw writes to an unformatted drive with no file system, you can get rid of a lot of crap. For me, it's not as much about performance, because I don't know that disk IO, I'll know more when this is deployed in the wild. I haven't been sweating disk IO, because I don't know that we really are going to care that much about disk IO. But for me, it's not about speed. It's about reliability. The less of this crap there is, the better, in my opinion, because Linux is just a janky pile, and I don't want any of it running. The kernel may be sort of okay, but the user space definitely isn't. So ideally, I would like to, if not in the first incarnation of our server stuff, because like I said, you can only do so much, but I want to minimize it at least. And then going forward, I would always want to remove user space stuff from our servers until we're basically down to nothing, where it's just our code running is the only thing running in user space, would be ideal for us, because again, it just gets rid of a huge maintenance headache, because none of the Linux user space stuff is good, and it doesn't do anything, right? That's for if you're a user of a machine. A web server is somebody who just wants complete control over the entire machine and just uses all the threads to serve stuff, right? It doesn't want other processes running, right? There's no benefit to those other processes if your server knows what it's doing and has all the features it needs. You don't need those, right? Let me check to see. Sorry, I wasn't looking at chat there. Does that kind of make sense? There. Oh man, there's a lot of chat. That's good, I guess. Okay, so yeah, I've read the sequel. Thank you for putting the Q colon in there because the Q colon makes it easier for me to see. Does the scheme used here have similarity to command buffers in GPU? Also, what is the significance of these APIs featuring queues just storing commands? What benefits does it have? So yes, like the way you can think about IOU ring is very similar to how you can think about GPU command buffers. They're very, very similar. The primary difference between them is only that as far as IOU ring is concerned anyway, I don't think there's any chance at all. I mean, there may never be any chance. But at least currently, since IOU ring is very new, there's no chance that the IOU ring stuff is getting implemented in hardware. IOU ring is more just a way of packaging a syscall into a ring buffer so that it can be executed without the syscall, right? When you think about GPU stuff, depending on what circumstances you're talking about, you could actually be talking about something that actually gets executed on the graphics card. Now, that would be a really cool thing to happen in the IOU ring space, and there actually is precedent for that. There are things like, what's the name of that stuff? In InfiniBand. So there's things like InfiniBand or other things that are in the server space that are like all about like high performance, kernel not involved nonsense to like communicate between machines and stuff. So there obviously is high-end hardware that does have some of that stuff, but it doesn't have anything to do with IOU ring as far as I know. There's no integration between those two things. They're just separate. Like InfiniBand, I think, is a thing where you can basically say, like, I want to map this memory across multiple machines. So basically, like, it's like a backplane, like a back channel that'll like sync the memory. So if you write something, the other machine will see the writes, like in the data center, right, and things like that. And again, the point there, it's not going any faster, right? It's still going over a wire, so it's going the same speed as anything else. But the idea is you can reduce a bunch of overhead. If there's a piece of hardware sitting there that's just looking at, you know, this sort of mapped memory and feeding it to other machines really quickly, it can get rid of all this overhead of the kernel ever even having to know, right? So again, a lot of this stuff is just about getting the overhead out of the system. When you ask the second part of your question, which is what is the significance of these APIs featuring queues, what benefits does it have? That's the benefit, right? So that, oops, I didn't mean to do that. I just accidentally locked my own thing that I was using to read chat. Oops. Okay. So the significance there, just to draw this, because I didn't do a very good job drawing that diagram, obviously, because I was talking about the buffer flow there. But if you think about what actually occurs when you do one of these syscalls, right? So if I want to do something like a write syscall, so you know I want to do something like a write, not fwrite, because that's like one level higher, right? That's the buffered version. If I want to do something like a write syscall, so I'm calling Linux, and I'm going to actually issue like a direct write for the syscall. And you can look up in the table, there's like a syscall called write. That syscall. What's going to happen in the assembly language is you will literally see a thing that says syscall. This is an actual instruction, like on an x86 CPU, right? And what the syscall instruction does is it's basically a transition to the operating system that's designed to happen quickly. And what happens is the registers are the parameters. So what will happen is your code will go like, okay, set, you know, this register to the file handle, set this register to the address, set this register to the size, syscall. The operating system goes, oh, what's going on? Oh, a syscall, which syscall? Oh, one other thing was write, which thing you called, that's in a register too. You put a number, the number is which operating system function you wanted. You look in the table, you'll see like write is, 7 or something, right? That's how it knows what to do. So it wakes up and goes, whoa, what's in register blah? Oh, it's 7. I'm going to do a write. It's not 7, by the way. I'm making that number up. Go look at the table. You'll see. So it's like, okay, that's what I needed. I'll go do that one. I look at the other registers, find out what I need to do. I'll actually process this here and shove it off. And then when I'm done, I'm going to detransition, right? I'm going to go, I took a ring transition down to the operating system to do this syscall, and now I'm going to transition back to user space. So you're constantly doing that ring transition, which costs, right? You're paying for that ring transition. And not only you're paying for that ring transition, but you might have to pay for like saving and restoring registers. Like all sorts of stuff could have to happen here because you're effectively going from your code with all the registers set to whatever they are and the memory map being whatever it is into the operating system, which has to wake up in the middle of that, no context at all. And it has to like go, okay, let me like get everything set up. Let me handle this thing. All right, I'm done now, and let's get out of it, right? So that inefficiency of this, of filling out the registers, doing the syscall, and taking that ring transition overhead, where it's like kernel transition and back, kernel transition and back. If you're trying to do a lot of writes, you're wasting all your time doing these syscalls. Like there's no point to these things. You're just sitting around doing it. You'd like to be able to start doing them in bulk. That's what IOU ring basically gives you. So the reason that these things tend to look like a queue, and that's what they look like, by the way. So they tend to look like this. These systems tend to look like like an in and an out queue, right? And they've got like, chunks. So your application, like it puts something in here, right? And the OS reads it and writes the output here, right? It like reads, writes, reads, writes. And they don't have to go in order. So you might read these and like, if this one took a really long time, then maybe this one actually goes here, and this one goes here, and then this one actually goes like all the way over here, right? So the reason that these queues work well is because now you don't need syscalls at all, right? All you do is just slam all your data into this command buffer, and the operating system's just reading it. You're writing it, it's reading it. There's no need for a syscall at all. You can just keep going like that for as long as you want. And the only time you ever need to make any kind of syscall is just if you look. So I've never looked at the actual code, so I don't know exactly what they do here on Linux. You can check. But if this thread goes to sleep because you didn't have anything in the queue, like it finished, it read up to here, and it goes, oh, there's nothing. I looked at the index, and this is the last one, right? I don't need to read anymore. They haven't filled out anything else. It may go to sleep, right? If it goes to sleep, you need to wake it up. So if that happens, then there would be a syscall to wake that thread up. But if you think about it, in that case, it's probably okay because you couldn't have been doing anything that high bandwidth if it underflowed. If the operating system like got to the end and was like, I'm done. So in the scenario where you care, which is where you're just writing tons of new blocks and you just want to slam all these things into the buffer and just like have the operating system just like picking them off, writing them, right, without ever having to do all these transitions. That's the case where you actually care about avoiding tons of unnecessary syscalls, and that's where you're not going to have to make any. In the case where this thread goes to sleep, well, you couldn't have been doing that much work anyway because obviously you weren't calling this very often because you called it so few times that the kernel beat you to the end of it, right? So that's one thing you do have to do. Now, I believe, again, I don't remember because I don't program Linux. Right? But, I had to look at how they do it because I needed to program it this one time. I believe the idea would generally be, because in these sorts of systems it usually is, you don't call it every time you insert something either. You insert all the things you want to insert, and anytime you want, you can call to check to make sure the thread's awake. So also, you can make sure that you don't tend to like stutter much because you can make sure you dump a bunch of stuff in there and then kick it off if you want to. Now, you don't want to wait too long because you want the operating system to be like to get overlap, but that's basically the idea. And so, yeah, it's exactly like a GPU in that way. You're just filling up these buffers so that you can both do work at the same time. Right? But it's a little bit unlike a GPU in that in a GPU, expect some of this work to be done by a processor that's like a different processor than the CPU that you're on. Whereas in like something like IOU ring, you're actually talking about the same processor. So you're just talking about two cores on that processor using this to avoid having to do a bunch of syscalls on the same core to do this. So off you go. There's probably also some other benefits. I don't know. I haven't worked with IOU ring much. But you can think about there might be some other benefits too. If the kernel thread is just doing its thing and your thread's just doing your thing and you're on separate cores even, then you're not going to be polluting like your L1 and L2 caches. Every time you hit one of those syscalls, anything that the kernel needs to go touch for pages of data that need to actually do stuff, such as like ext4 like metadata or Btrfs metadata, or stuff in the kernel that it needs to check for permissions, or I don't know, right? Like who knows what the Linux kernel does? It's like 30 million lines of code or something at this point. Whatever it's doing in there, if those are on the same core as when you did your syscall, that's polluting your cache, right? That's taking up space in your L1 or your L2. Whereas if you're two separate threads on two separate cores, each doing your own thing, you'll get a lot better cache coherency because you're just touching your stuff that's in L1 and they're just touching their stuff that's in L1, and you guys are never like fighting over which cache lines are going to be resident in your L1 or L2. So it seems to me, and I've never profiled this, so don't take that with a grain of salt, but it seems to me that there probably are other wins you could get there as well that aren't just about avoiding like syscall overhead or avoiding, unnecessary buffering and things like that. But yeah. Okay, so there was a question here before it scrolls off. In one of your very old Handmade Hero episodes, you were talking about how you would like to program on Linux, but Linux debuggers had always just been worse than the mediocre Visual Studios. I do think that using GDB is not actually great, but I'm assuming there were and are other options. Could you maybe go more into depth on what makes debugging on Linux that much worse than using the monstrosity of Visual Studio? Yeah, so actually, when I said debugging on Linux sucked, I actually meant all of it. So I agree GDB is not great. And to be clear about that, it's you have to be careful when you say GDB is not great, because GDB actually really, I mean, I don't like using it and I don't use it very much, so I can't say like definitively. But in my experience, GDB has a lot of features. So usually it's not that GDB sucks because it doesn't do the thing you want it to do. Usually it can do whatever the thing is that you want it to do. And maybe there's some edge cases there, but it has a lot of advanced features, GDB. The problem is like the usability is terrible. So you waste so much time hunting for bugs with GDB that you could have just found them easier some other way, like with a printf log or by just putting in more asserts in your code or whatever you could have. It's not going to save you time. And the only point of a debugger is to save you time, right? I mean, most of us would presumably agree that we will find the bug eventually because we can do work in other ways to get to the bug. So it's not like a debugger is the only thing that can find bugs. The point of a debugger is to find the bug faster. If the bugs are actually getting found slower when using the debugger, that is a useless utility. And GDB to me is exactly that useless utility. With the exception of just telling you like where your code crashed if it zigzagged or something, it really can't find bugs faster than you could find them yourself without it, right? And that's why I think it's kind of crappy. The same tends to be true of almost all debuggers on Linux. They're really slow. Trying to step through them is arduous. They oftentimes can't display local variables properly or watch window stuff properly. Most of them can't show disassembly. There's like very few that can actually show disassembly. That's a very important aspect of a debugger if you're a serious programmer, is to see the disassembly. It's just a mess. So I'm actually talking about everything. I tried probably 10 different debuggers, maybe 15, the last time I looked for one, and they were all universally horrible. I think the thing I ended up using the most was Qt Creator, which kind of sort of has a debugger that works, but it's really bad. It was just like the least bad of the like 20,000 like Clion and Qt Creator and this and CGDB and that. I will say that at that time, NacST, the guy who does the Essence operating system, he recently wrote a front end for GDB that people have said good things about. And I mean, since he writes his own operating system, you kind of know that's a certain level of competence as well. So I haven't checked that out yet. When I actually go to do debugging of some of this stuff on the actual servers, I will probably try to get that running because I'll probably need a debugger here and there when I go to move it from the local machines to the Linux server machines, I anticipate obviously there'll probably be a lot of nasty debugging that I have to do to like get everything proper. But I can't really speak to that because I haven't tried it yet. But that's on my list for sure. Okay, what exactly are we at for questions here? Let's take a look. I'm going to take a little sippy poo here. The mic's a bit hot. Yeah, is it too loud? I assume this one's fine. This one looks fine. Is it just the other one that was too hot? So here's the problem. I don't actually think it is too hot. I think there's just a weird clipping problem. I don't know what it is. It may actually just be OBS, but I have to root it down. There's definitely some kind of weird like sound anomaly, and I don't know where it's coming from. I don't. It's something I gotta root down, but I don't know that it's the actual board mic. I can try turning the board mic down a little, and see, but I don't know that that'll help. On the topic of syscalls, the kernel has its own address space, right? Or is it just protected and not accessible from user space? Can it copy user memory in? So it's kind of the wrong way to think about it, a little bit. So let me just make sure we're all on the same page with that. So memory is just memory. You have physical RAM in your machine, and the RAM has the data in it. The thing that is different between you and the kernel is the mapping, right? So your process has a mapping that says which addresses go with which physical RAM chips, right? Like how do you map them? And it has protection bits that says whether you're allowed to read or write from them and so on as well, right? So the real way to think about it is that when you do something like ask the kernel to do something, it's really the kernel's discretion. Like if the kernel wanted to, it can just work with your memory layout. The reason that usually something has to happen there is because the kernel wants to hide stuff from you, or maybe doesn't want you to know where things are, right? So it has to do work with the setup of the memory page tables to make sure that you can't access a page in physical RAM that it wants to keep hidden from you, right? But it's not like you have to copy user memory in necessarily. The kernel can access your memory just fine. The reason it may have to copy something usually is because of some other constraint. And the other constraint is something like the following. A, you made a call that appears instantaneous, but it's actually slow. It's actually latent. The example like we gave with write, like I'm going to write this stuff somewhere. Well, I need the contents of the buffer that you passed to write. I need that to remain valid until the disk actually finishes committing it, right? So because I want it to appear instantaneous to the user, I have to copy it out of that buffer into something that I know will stick around, right? So that's thing one. Thing two is the exact same thing is true, not for the buffer, but for the mapping of the buffer as well. So in other words, if the VM system might wake up in the middle of this write, even if the user promises to not change the buffer for a while, if the VM system might wake up and change the mapping of that so that it gets mapped out of that same physical page, well, the problem there is things like the disk, right? Like a piece of hardware, it doesn't go through virtual memory. So when I translated the virtual address to a physical address to pass it to the disk, if that then gets moved or whatever, that whole write falls apart, right? Now it's going to write some other thing from that same physical RAM page that means something else, right? So typically the reason that the copies happen is not because the kernel couldn't just read your memory. The kernel can read any memory it wants, right? The problem is actually that the kernel usually is trying to pretend that something is instantaneous that's not, and the consequences for that are that it has to do a copy to put it somewhere that's okay, right? Now, there's other reasons for the copy too. Like I said, one is to assemble buffers that are the right size for writing to things like disks. So sometimes it has to like assemble things. You can think of this as very analogous to assembling cache lines in a cache. Like when a CPU can't write like a byte of memory, right? Like that doesn't happen. When a CPU tries to write 1 byte of memory, what actually happens is that 1 byte gets assembled into a 64-byte cache line, which then gets put out to the cache, which then gets put out to main memory, right? So there's like these write combining buffers that are there to assemble, right? And the same happens in the OS. It has to assemble things that are the correct size for use with hardware, because the hardware doesn't just arbitrarily take like individual byte ranges and work with them. Someone said, I believe the original question mentioned this, but if not SQL, what are you storing, and what does the interface to get that data look like? Raw read as well, key values. Yeah, so it's basically just custom coded. So because the server, so I mean, I'm an architecture person. I like working on these kind of problems. So like the last thing I'm going to do is have like a weird like structured query language to do stuff, right? Like it's just going to be like a nice little interface. You can just write raw C code that just works, right? So it's just custom. Whatever it needs implemented, it implements directly on top of that raw write system. And it's flexible, right? Like it doesn't, I don't make like a Procrustean SQL like bed for like all of my stuff to have to sit on top of. Because, especially when you think about the fact that like SQL is not really meant for many things. It was really just meant for like transaction processing, right? And a lot of things you do on servers aren't transaction processing. Some things are, like maybe the purchase of, Star Code Galaxy, where you try to click the buy button. Maybe that's something that kind of looks like what SQL was designed for. But the rest of the stuff, anything else that there is really isn't. Serving you back stuff to when you try to read stuff that's on the server, like you're trying to get like web server stuff to you, like it doesn't look like SQL. Like SQL just wasn't designed for that. And so it's not a very, it just isn't very useful. So the reason that people use that kind of thing for that nowadays really just tends to be because it's just what was there. And it's very robust, right? Because like transaction processing was a very well studied problem. So you can go buy something that probably won't just, light on fire and explode. But it's usually not the right tool for the job unless you're literally doing, like an ATM machine, SQL Server, or like a parts database where you have to know exactly the number of screws left in the inventory or whatever. It's just not really, it's not really that useful for a lot of things you do. Have you looked into eBPF? No, I have seen that mentioned, and I even looked at what it was. I thought I looked at it and said, oh, I don't need to know about this, is what happened. But Maybe I'm wrong. Oh, right. This is the packet processing thing. Yes. No, I have not looked into this. I don't think I care about it, but I haven't looked into it, so I couldn't say. I did see it mentioned, yes, but no, I haven't. I haven't looked at it. Oh, okay. Windows is adding an IO ring feature. Okay, so I see what the question is. Why does it need? Okay, so I've read the sequel. You're asking why Windows needs to add IO ring if it has IOCP. I haven't looked at anything Windows related that looks like that, so I don't actually know very much about what Windows is planning to add for IOU ring. So I really couldn't comment. What I will say is IO completion ports are not solving the same problem. So IO completion ports, the problem that is solving is how you have multiple threads on the user side responding to completion events from the system side. That is what IOCP does. It is not designed for high bandwidth outbound stuff, so it doesn't really have anything in there designed to be a low latency IO dispatch, right? So at the very least, you would think that would have to be there. But the other thing to think about is that, again, it's still a call. The interface to IOCP is a little clunky. You have to call, get me all the completion records, and they copy them into your buffer. That's not really what you want. What you wanted was a index you read without ever calling the operating system, and you see what it is, and that tells you where in your ring buffer to read up through. No operating system involved, right? So again, it's about getting the calls out. This is how operating systems should always have worked. By about 1990, we should have started moving towards operating systems where this is all you did, right? You should just write into memory and do it, because that's how old home computers used to work, right? You know what I'm saying? So really what you want is just memory you write into that says, here are all the syscalls I want. That's how an operating system should always have worked. Here's all the syscalls I want. And then I just look at an outbound queue to see which one of them are done. Like, that's what you wanted. That's what you always wanted. And it's what you had to a certain extent. Although it was more interrupt. It was more like, because, a single processor. So what are you going to do? You're going to interrupt and do it right there. But what we should have moved to as we got more cores was that, and we didn't. So, somewhere in the 2000 to 2010 timeframe, we really screwed up. And now it's just a question of trying to get back to normal. How do you organize the data? Well, that's a very, very involved conversation. It would not make very much sense to anyone other than me, as I guess I would say about how I organize the data. Are overlap sends not going to be as performant? Yeah, I mean, overlap sends require you to actually call a function, right? That function doesn't have to do a syscall. It could be a local call, right? But it still has to do something. It's not just writes. You have to remember there's a big difference between calling a function and writing to memory. Calling a function means you have to put a bunch of stuff into registers. You have to issue the actual function call. That function has to do some crap. It has to do the write you would have done already, and then it pops out. The compiler cannot optimize around it because it doesn't know what that call does. It's a system call, right? It's not a syscall, but it is a call to a library that the compiler can't see. So it can't do a bunch of optimizations. If you're talking about something where you just know there's a flat memory, you know the format you need to write to, you can write code that blasts that in there really quickly, and the optimizer can optimize straight over it. Everything just works. There's no call involved. None of that, right? And so, again, I don't know the details of the Windows one. I can't really say, but I just want to point out what the differences are there. There's a big difference between calling functions to do stuff and just writing to memory. Writing to memory is always a superior option. John disagrees with me about this, by the way. I don't know if he's still here. But we had this argument once, and he didn't believe me. So you could argue with him about that, because I was like, you never call functions to prepare stuff to send to the OS. Like, that's not what you want. What you want is just you write flat memory out, and the OS picks it up out of a queue, right? But John was like, no, you should have a function that you call, and then that thing just does the whatever the format stuff is that needs to happen there, right? I mean, I guess one thing I would say is it's probably the case that you could find reasons why you would do one or the other, so it's not like there's a right answer. But for me, I always go the other way. I'm like, no, you just write everything, right? I would be totally fine, yeah, with an API that it was just both ways, yeah. Because then it's like, look, if you can make performance gains by just going the memory route, then do so. If you just don't care about that very much and you want to make sure that, you know, it just does it the way, you know, it thinks it's best, you just call this function and it will do it for you. That totally seems fine too. Yeah, absolutely. I just always want the memory one available because that's what I would usually use. I think it also reduces dependency. Like, now I don't need that function, right? I know that I can just make this flat memory. It just I feel like it simplifies my life a little bit as well, but you know. Either way, the idea here is just that the ring structure is much more efficient. So even if you're going through a function to do it, it's just going to be that ring on the other side of that function anyway, right? So that's might be why the Windows people are doing it. Maybe they already have that ring is happening. They're just like, let's just expose it, right? Do you have any tips in general on how to go about reading and understanding old large code repositories? Yes, sir. Get them building and step through in the debugger. That's how I do it. Let the debugger walk you through how the code's working. It's way easier, in my opinion, to do it that way. Get a good debugger and step through it. Yeah. John says, I think the actual big frontier in software that everyone ignores is we have to make ways for people to do things somewhat easily without making it impossible to do the efficient good version. I totally agree. I mean, this is part of the whole, like, graphics APIs should probably just have been something on GitHub, right? And then the vendors just, like, publish the damn memory thing you write, you know? Because it's like, we end up with this weird in-between where it's like, you end up with something like really messed up, like Vulkan or whatever, where it's like half a raw memory API, but half a like user API that's supposed to be doing, like, we end up in these really weird zones of like that, or the total ridiculous thing of like no thought was given to the efficiency, and it's just like it's like Qt or something, and you're just like, oh my god, right? So yeah, it's bad. Like it would be nice if we just said, like, we're always gonna have a really clean low level thing where you just write to memory and you don't ever call anything basically, and it works, but you have to be a pro to do it. And then if you want, go to this GitHub and get these libraries that will do that for you, and you call those. But they use the good thing underneath that like anyone could use, so you don't have to use the library if it sucks or whatever. It would be nice to get somewhere more like that instead of like they ship both things. Like we have something that's supposed to be sort of easy to use but also sort of performant, and it ends up being neither, right? Or they ship it and they know it's not performant, but there's some lie about how it's going to get performant and it never does, right? kind of like the C++ optimizer. Like it's always like the optimizer, like it's going to get better, and then all these problems are going to go away, and then like it never does, right? So you have these weird like vague promises about why this will eventually be good. It's like, well, no, like it probably won't. Are you doing any sort of checksums or parity codes on disk writes? Absolutely. So when you write out data, you pretty much always want to hash it, right? You really, really want to know if the data that you wrote out comes back the same. So absolutely, yeah. I store redundantly and I hash it, so I know when one of the redundant versions is bunk. Yeah. Yeah, the eBPF stuff, I don't know. 1-bit brain, it just looked like I was like, I don't know if I care about this, because it just looked like possibly a bad idea, but yeah, I don't know. Maybe it's great. It is true that in that space, you often have ridiculous stuff like microcontrollers designed to do packet filtering, and they all have their own like little like language thing and whatever. So like maybe it's good to just standardize that. I don't know, like the Linux kernel is kind of going off the deep end these days, so I don't know. I feel like they've piled too much complexity in there, and it's not a good thing. Like that's not going to be good down the line, right? 3dfx Glide was just OpenGL really. 3dfx Glide is not. It is just pretty much just OpenGL. It's slightly different, but. But like if you could program OpenGL, you could just program Glide right now. Like you would barely know the difference, I think. It was OpenGL back in the day, though. So we're not talking about like modern OpenGL. We're talking about OpenGL where you called like GL vertex for every vertex kind of thing. That's what Glide was like. Yeah. All right. I should mention. So how are we doing here? 8:27. Got about 30 minutes left. So we can do some more questions. Here in this programming AMA. By the way, I don't know if you guys got to see it. I've got the book 1 comic book here. It looks pretty awesome. So if you're interested in checking out the Kickstarter for book 2, you should definitely do that. I tried to put a link at the bottom. I love the print job that they did on this thing. As I said before, it's really kind of awesome. If anyone out there is an artist who wants to print a comic book, you should totally use this printer because they're that good. It was really educational. They just have like such good, like it just came out so good. And they even did the spot UV on the front. It just looks really good. Anyway, yeah, check out our Kickstarter if you don't have questions. The link should be in the bottom, but I'll post it now. Yeah, let me see if I can get it to focus. Here you go. I have the contrast turned way down, so you can't really see how vibrant the colors are, of course, because that's just, I don't like super vibrant webcams, but it looks really good. Like, they're so good. This printer was awesome. There's so many things that you don't know about printing until you work with a really good printer. Like, to get all of the stuff really crisp and the colors just right. They are so good. It looks way better than most of the stuff we've got from other places. Like, we've got comics on the shelf here, you know. And a lot of them just don't look that good. Like, the colors are kind of not that great, and like there's the edging is not perfect, or it's a little bit blurry or whatever, right? And this place was just awesome. They were so good. They're here in Seattle too. They're like local. It was awesome. But anyway, yeah. If you don't have book 1, the Kickstarter for book 2, you can get book 1 too. So check it out if you want a good feline space opera. You know, you would be hard pressed to find a better comic than Meow the Infinite. So we need some more questions here. Besides all the horrors you've seen in regards to getting desired hardware and performance in your server work, what have you found on this endeavor that's been pretty interesting? I mean, it really depends on what you're talking about. I guess I would say, programming-wise, I think I was pleasantly surprised by Wasm, um, the WebAssembly spec. It's not what I would want exactly, but it's like fairly simple. Like they were like, look, we're just gonna have a few instructions. They fit on like one simple HTML page. Like, here's all the instructions that are gonna be. It's just gonna compile C to it. There's no, like, all the M script and stuff and all that stuff is garbage and stupid. But the actual just, hey, I can put together a little assembly language and I can send it to the browser and it works. I was pleasantly surprised because everything else I've ever seen from the W3C is like the exact opposite of that, right? It's like thousands of pages to implement a simple layout language that doesn't really work, right? Like CSS or something, right? So like I feel like the people who did Wasm managed to avoid the thing that all the other W3C specs do, which is end up with gigantic piles of API, and then they still don't frickin' work, right? The Wasm stuff, like, kind of works. Like, it kind of works, and it's kind of simple. It's by far the best thing I've seen out of the W3C. I wish they had... there's a little bit... So, they haven't really figured out good answers to, like, how you get memory working exactly right. And that's unfortunate. The single 32-bit address space thing that they do has... It really limits what the code can do in terms of efficiency. Like, that's not good. I would really have liked it if they would have tackled that head on and appreciated the importance of the MMU. Okay? But that said, I'm not talking about this compared to the ultimate thing. I'm just talking about this compared to everything else that is in your browser. This was surprisingly good to me, right? Because everything else that's in the browser is nowhere near usable, right? It's not like with Wasm, I'd be like, okay, here's the things I think maybe we could do better here, right? The thing you could do better with CSS is throw it away, right? It's complete garbage. There's nothing good about it. I have nothing positive to say, right? So if you take a look at the difference between something like CSS and something like Wasm, I just think they deserve some credit for not doing the thing that they always do. So the people who did Wasm, I really like the fact that they stayed out of some of these disastrous traps that all the other web tech has gone down. And so that was pleasant. It was really freaking easy to get my Wasm stuff working as a thing to ship for our client code. The compatibility may not be fabulous yet, so, we'll see about that. But I'm just saying it's off to a much better start, right? It's off to a much better start than these other things where you just look at them and you just go like, oh my God, What are your thoughts on CPU side channel attack mitigation seriously affecting the performance of memory mapped files and I/O in general? Do you think the APIs should have a way to opt out of that? I've seen 2 to 8x performance loss in my code because of this. Wow, really? 2 to 8x performance? That's crazy. So I guess what I would say is I don't have a lot of experience with it. Thus far, I have not had the... I've never had the experience of finding out that the reason that my code was running slow is because of a side channel attack mitigation. So I have nothing to add. I do think that being able to opt out of them would be a good idea. The reason for that is just that if you're running a dedicated server, there is no side channel attack, right? Nobody is running code on your machine, just you. So no one can do Spectre, no one can do Meltdown, no one can do Rowhammer, right? And the only way anyone's ever going to mount an attack like that would be if they found some really good exploits about how to get your code to issue the attack on itself. And I just don't see that being very plausible. There are plenty of side channel attacks that work on servers, but they're usually side channel attacks like leakage about how much time something takes, right? They don't tend to be to the time, like actual wall clock time. They don't tend to be down to the kind of like cycle accurate sort of stuff you probably have to do for side channel stuff. And also they wouldn't be able, like, nothing is going through a ring transition, so that, like, I'm not sure where the side channel part comes in, right? So you pretty much have to defend against those things already when you're writing a server, because of the user space attack as well that happens there. So I'm pretty sure it's just not an issue. So it would be nice to disable some of those because they're really just not an issue for servers that aren't running other people's code, you know? But, you know, who knows? I don't know. What's the thing you're most excited for or proud of you've been working on in the last 12 months? Like the most positive thing? I guess there's two things. I don't know. I'll say two things. So one thing is the distribution algorithm, like how the architecture is for our server thing we're deploying, for how it scales, right? So how you add more machines to it. It's also the thing I'm most terrified about, right? So like, I think I did a good architecture for that solution. It's a very hard problem. It's the hardest problem you face in server design is how do you run many servers without the cost of running many servers, without the communication between the servers, like, you know, limiting a lot of the gain you get or creating bugs or creating slowdowns, that sort of thing. I'm excited for how I solved that problem. I'm also terrified because the only way you ever know if that works is when you get like 8 machines deep because people actually liked your service and you had to add more, and then you find out it doesn't work. Right. So, you know, I've been trying to war game it out as best I can, but there's nothing that's the same as actually deploying, right? I mean, there's nothing that's the same as you can try to simulate all you want, but nothing is the same, exactly the same as when you actually deploy. So, you know, so there's that. The other thing is stupid, but I actually am excited about it, which is the Starcode Galaxy, the text version. There's like a thing at the beginning of Starcode Galaxy. The first things you do is like a text, it looks like a roguelike kind of thing, you know, like you know, the old school with the ASCII text thing. And I did some stuff in the code base there that I thought was pretty fun. Like, you know, you'll see when it comes out. It's stupid. It wasn't hard or interesting really, but it was just like, oh, it was kind of fun, you know. So there was some fun stuff in there because, you know, I never got a chance to do one of those ASCII dungeon things, so, you know, it's pretty entertaining. Yeah, Lucid Frost, 5 to 10% sounds more like what I would have expected. The 2 to 8 times just doesn't sound right. Are you sure that's what it was? It just sounds wrong to me. Now, I don't know, because I don't, you know, like I said, I've never really hunted down a thing like that, so I'm not prepared to say that you're wrong, because you may be right, you know? It just 2 to 8x just doesn't sound plausible for a side channel mitigation. Is the small instruction set for Wasm liable to be enough? x86 is a big ISA, and I imagine much of that variety provides value. So I think what I would say is, obviously, you're not wrong. You're definitely going to lose some things because you go to a smaller instruction set, and x86 gets some power out of being this big old beefy nightmare instruction set. That's kind of one of the things that it gets power from, like having memory operands for everything, and having these gigantic long instructions that do 50 million things or whatever. No question, right? But you have to remember, not everything is about taking advantage of maximum performance. And one of the things, so it's important to distinguish. When I get really angry at web technology, it's not because it's slow per se. Meaning, I'm usually not angry that web stuff is slow and that's the only thing. It's just I'm just angry about the slowness. What I'm angry about is it fails on all fronts. It's slow, it's buggy, it doesn't actually work right, it's ugly, it's unreliable, right? So it's kind of like they had a problem to solve, many problems they could solve, and they solved none of them, right? The thing I like about Wasm is it seems to actually solve a little bit of a problem. Is it going to be the fastest way to run x86 code? Absolutely not. Is it going to be relatively fast? Yes, right? It's relatively fast. It supports threads. It supports arbitrary addressing. It just can't do the full 64-bit MMU stuff, which is a bummer, like I said. It has 128-bit SIMD support. Not all the instructions, but a lot of them, right? And it's very simple. The instruction set fits on a couple pages. You can read it. You can understand it. You can look at a disassembly, and you can see what it's doing. That's a success to me. Is it the best on any particular axis? No. Is it a reasonable solution to a real problem that I feel like I can use to deploy something that will actually work and that I won't hate and that is fast enough to be usable and reasonable, have a good user experience? Yes, I do think so. I think it might be. We'll see. I think it might be. And that, to me, is a success. Coming from the W3C, that is a success, because most of their things accomplish none of those. They aren't fast enough to be usable. They aren't reliable enough to be usable. They aren't precise or rigorous enough to be usable, right? So if Wasm had tried to have like 8,000 instructions, I think that might have been a mistake, right? Yes, you could have gotten some more performance out of it by having a richer target, but you lose something. You lose the simplicity. And it makes the transpiler harder, the thing that actually goes and turns that into machine code that's in all the browsers. It makes that easier to screw up. It makes it more likely to introduce slowness because the transpiler sucked, right? So you have to remember there's multiple things they had to optimize for when doing something like Wasm. And normally that is the kind of thing that W3C just completely fails at. And in my opinion, they did not completely fail this time. Wasm is not the horror show that their other specs are. Is it as good as it could be? No, but nothing is. Do I hope it gets a little bit better over time? Yes. But is it an epic disaster? No. And that is something, however small, to celebrate when it comes to the web. Right? I'm a young dev working as a front-end developer, and I feel like there's not much I can do to apply handmade principles to regular JS coding day-to-day. Do you have any tips for doing that when you have to work with a standard front-end HTML, CSS, JS stack? I mean, yes and no. What I will say is that, obviously, if you can use Wasm, well, there you go. You can compile C right in there and run it inside your JS just fine. So that's one way to pull the escape hatch. But one thing I would say is HTML, CSS, you can program that more low level, right? HTML, CSS, JS, you can program that more low level. You can. Instead of like using 20,000 frameworks and like calling like React and all this stuff from JS, you can actually think about like, how do I write very straightforward, simple JavaScript code that does what I actually needed to do more efficiently, and you will see the benefits. When you don't have to download this giant React.js framework that just dumps all this crap in there, your pages load faster, they run faster, they're less buggy because you can see, when you wrote exactly what needed to happen. So you can apply handmade principles to anything. It's just don't use more than you have to, it's just being, frugal is what it is. So it doesn't matter what you're programming in. You can still cut down on the crap. So if you have to program JS, yeah, it's an annoying language. It sucks. I mean, it does. JavaScript is a terrible language. But hey, I mean, you can still not use all these bloated libraries, and you can write your own little custom stuff that's cleaner, more straightforward, and more likely to work. And it will have benefits of being faster because your page load times will go down and your interpreter times will go down, right? That's cool that you can turn mitigations off by putting mitigations off in a set sconfig grub. Okay, that's cool. That's cool, yeah. Interesting. Mitigations for 2.8x on a NUMA system with MCDRAM caches. On a regular desktop x86 64, it's about 15%. That's such a big difference, right? Wow. Yeah, I've never had that experience, obviously. Oh, Freak CS, yes. So Starcode Galaxy is coming. When I get the this server system deployed, then I will be working on getting it out. Runs on top of it, basically. So the coding course is Starcode Galaxy. I sent out a mail today, in fact. Those of you who are on the Starcode Galaxy mailing list should have gotten a mail today. Hopefully everyone got it. StarcodeGalaxy.com has a little sign-up sheet. I sent out a mail, and it talks a little bit about what we're working on and what's still to go. So in ref term, you annotated the headers and seem to have split things up to make things like the glyph table used like a library. Would you say that's a good example of an API you made? Yeah, I mean that was a weekend project, so I don't really want to say it's a good example of an API, but that's just how you ship code sanely, in my opinion, right? Like if you go look at that glyph table, it's pretty easy to use, right? I made sure that the things you call make sense, that anyone could grab it and drop it in, and they'd be unlikely to screw it up, right? Could I have done more, though? Definitely, sure. But if you look at that glyph table, you can see that, I took a little time to make sure it was easy to drop it in, and, it's probably not the best API I could think of, like if I went and thought hard about it, but it's a usable API. And more importantly, it's an API that comes out of having written the thing that needs to use the API, so I know that the API fits into place properly to a terminal, right? Which is also that's the most important thing in an API, right? Is that the shape of the API is useful to the people who want to use it, and they don't have to do all this code to work around the fact that the API doesn't naturally call the way that you need it to for the problem it's supposed to solve, In the printing creation of Meow the Infinite, did you have to write and code? So I'm not exactly sure what that question is, but actually I did write some code for Meow the Infinite. So let me show you. Book 2. So the Kickstarter that I posted, the Kickstarter that we're running right now, which please check out if you get a chance. It's got a cool trailer and everything. I'll post it here. I don't know if I did any code that would be used in book 2, but in book 1, and some of you know about this because I posted it on my blog. In book 1, there's this character that's like this creepy automaton cat. Let me show you. So there's this like ancient mechanical marvel, right? It's right there. It's called the Prime Puss. And you can go to have an audience with it, right? That's one of the things that you can do in this world is like people go to have an audience. You buy. Let me just show you. Sorry about spoilers. If you don't want spoilers, plug your ears for a second. But you would have you would have already bought the book. So you go to this place called Comet City and you buy one of these little tickets, right? And you can have an audience with the Prime Puss. And it's this thing here, right? And if you look at the text, there was no real way to do that in like Photoshop. And Anna would have had to have like done all that by hand, and it didn't make any sense. Because if you look, I'll try to zoom it in even closer if I can. If you look, it's like all jittery, and the size, like I mean not the size, the offset from the baseline is different, and stuff like that, right? So if you look at something like that, it's like it takes too long to create by hand. So what I did is I wrote like a Photoshop script that does that for you automatically. It didn't take very long, but Photoshop has like a little like really crappy like JavaScript thing in it. So you can do stuff like that. Like you can go take the text and like assign randomized baseline. So there's like a little thing that you could plug in some numbers to, and it would just like randomize the text, and that made it a lot easier. So, yeah. Your email went to spam, but I found it. Thanks. Yeah, gosh. I don't know what to do about that. We tried to send out, so we used to send out a really bare bones email. I don't know, those of you who've been on the Molly Rocket mailing list for potentially years, because it's been around forever. Like we send out project updates occasionally to it. We've been doing that forever. I don't know that we used to have much of a problem with spam. But like somehow we now get filed to spam a lot. We tried this time to have ours not go to spam by making we made an email template that's a lot more like what you normally get for advertising emails or whatever, but apparently it still went spam. So I don't know what to do about that. I mean, I do know what to do at long term. It's just stop doing email. We need to like move past it. We need a new infrastructure for the web where people who sign up for things get them, right? Spam was a stupid idea anyway. You could have just had it so that people said which addresses they wanted to receive stuff from, and then they get them, right? You shouldn't even have to sign up for a mailing list. You should just put that as a thing in your email that's like RSS basically, right? So, yeah, I don't know what to do. I do not know why Gmail puts us in spam. Probably because I complain about how much Google sucks all the time. But I don't know if anyone knows how to stop getting us spam like that. It's really annoying. It's almost like it's one of those things where I wish you could just like sue them, right? It's like, look, people signed up for this. Your responsibility was to deliver this to them. You're calling it spam. It's like, what the heck, dude? Like, you have to fix this, but they never will, right? What email address was it sent from? It's sent via SparkPost. So it's sent via like a commercial email provider, right? And it has proper like if you go look at our DNS on mollyrocket.com, it has the proper like authentication stuff for proving that this is like a legit mail, one of those SPV, SPF, whatever the stupid thing is, right? And it's set up to be correct. And the weird part too is it never goes to spam for us, so we don't get to know that happened. So like it sucks. It really sucks. I don't know how to say it other than that it sucks. And I don't know how Google decides these things because of course they won't tell you. And I just don't understand. Like I don't know what you do about it. Since Google's an advertising company, they probably want to just like file everything to spam, so you have to pay them to advertise. It's not great. But yeah, it's really annoying because we'd like to be able to communicate with the customers who literally told us they want us to send them an email, and it really sucks that we can't do that, you know. But that's the way it is. So yeah, I don't know. Yeah, it comes from mollymail at mollyrocket.com. Yeah. Did anyone get it and it wasn't sent to spam? I'm curious if it. So weird. So like it thinks it's spam for some people and it doesn't think it's spam for other people. So I'm guessing that it's like depending on what things you've marked spam before. Like if you've marked things like that as spam, or maybe you marked ours as spam before because you didn't like it. I don't know. I really don't know because it's weird that multiple people, some people get it and it's spam and some people don't. And like I'm on Gmail, it doesn't go to my spam, right? Um, and like somebody posted that they have Gmail and it went to their spam. Why? Right? I just don't know. You'd think Gmail either thinks it's spam or doesn't think it's spam. But that's obviously not the case. So, how is it spam for one person and not spam for another? That, right? So I don't know how to fix that. And maybe we need to switch to a different provider. Maybe we should just switch to a different provider. I don't know. But I'd really like to get it fixed because it's very hard for us to communicate with people without it, right? Um, yeah, the Sendal, yeah. The Sendal ones go through. Who knows? No, there's not going to be any capacity for the SCG course. It's just its own thing that you can just buy. So the weird thing, I am Seabass, so the weird thing that I can't figure out, right, though, is because if it was a question of who it came from, then why aren't they all going to spam? Like, why do some people it doesn't go to spam for Gmail, and why do other people it does? So it just seems buggy. Because if they marked IPs as having sent spam, they should all go, like nobody should get it in their inbox, right? How is it possible that some people get it and some people don't? It's really frustrating. And I just do not know. So what we might try to do is like switch to a different provider. And see if that has any better luck. But I don't know what else to do. Like, I don't know who else. I don't know what to do. I don't think we could improve matters by serving the spam ourselves, right? Right. So if we try to send the email, I'm assuming that'd be even less likely to go through because then it's not coming from a known location. At least Gmail knows that SparkPost is the back end for lots of people's mailing lists, so they should be expecting to get it, and I don't know what's going on. There, but like at least it's not, they know it's not a dedicated spam house, but I really just don't know. But it's really nasty. I may have to just switch away. Like here's a question for those of you out there who might know. Who should you send your mailing list through? You know? Like, what's the way to send a marketing email? Because I honestly don't know. You want to use a commercial ESP like MailChimp or Iterable or whoever, but you have to warm your IPs properly. And you have to maintain the quality of your list over time. Like if you send stuff out and get poor open rates, you'll be penalized. But we don't include any tracking. There are no open rates. Like, what does that even mean? Like we don't have click tracking in our emails. So I don't really know. It's really troublesome though. This is a disaster. Like we used to have no problem. Like we used to send out the mailing list every week for a while and we had no problems. Fast forward a few years and now we just can't seem to, I don't know. It's really it really bothers me. So I don't know. Yeah, NXSY well, Neil, I know. I was wondering that actually. Like I was wondering if our mail looks too much like spam because it doesn't have a bunch of tracking crap in it or something. Which is if that were actually true, that'd be like the most offensive thing that's could possibly happen. You try to send an email to your customers that doesn't try to screw them and capture all their information, and you get penalized. I don't know, man. It's very frustrating, and I just don't understand. But yeah, email is garbage. I'm not sure what else you use. I mean, I can't post anybody on Twitter. Nobody reads my Twitter, right? But it's really bad. Like it's a massive problem, and like people should just be getting sued. Like I feel like someone should just class action Google about this. It's unacceptable, right? It's really not cool. Well, our mailing list has like 9,000 people on it. And like when we send out a mail, lots of people read it. If I post a tweet about something like one of our projects, it gets like 7 likes, right? Like nobody cares. So there's a pretty big difference. And that's with most of it going to spam even. So like the mailing list seems to work better even to this day, even with all the spam. But I just don't, it's really it makes me very unhappy. I do think there's possibilities for replacing it in the future with better things. And so we'll see. It definitely enrages me to the point where it's like, since we're distributing a server architecture, it has stuff baked in there now so that you can get updates from us directly without going through Gmail. Because of this exact reason, it definitely does just like increase my level of rage that just makes me want to frickin' destroy places like Gmail for being so frickin' terrible and not caring about their customers even in the slightest bit. It sounds like Hotmail / Outlook. I think they're the same, right? It sounds like somehow they just didn't accept it. This is terrible. It makes me so depressed. This is their only job, right? It's so ridiculous. It's just so freaking terrible. These companies need to go away. They can't do anything. Google is like one of the most incompetent piles of failure I have ever seen for a $1 trillion company. It's absolutely insane. It's just ridiculous. How hard is it to send text back and forth? The answer is infinitely hard if you're Google. Or Microsoft, as it turns out. Yeah, mailjet.com, what is that? I feel like Mailjet. So they're okay, but they weren't originally. Mailjet wasn't originally an SMTP server, right? That's a new thing, I think. But I think I'm going to have to switch away from SparkPost because it just doesn't seem like we get any good delivery. But maybe that's our fault. I don't know. Like I said, you can't tell because one of the problems with the quote unquote spam filtering is that they hide everything from you because they want to make sure that spammers can't work their way around it. The problem is that means legitimate people can't work their way around it. Like, they don't solve the problem by doing what they do. They're not solving the problem. You know? With the header validation, I'm seeing SPF pass and DKM pass, but none from DMARC. SendGrid is the biggest. What's DMARC? So maybe we have to add that. Maybe that was something that got added since then that I don't know about. So maybe I'll look into that after. But I just really want to get this straightened out because it's very depressing. And I guess the right thing to look at it is like I just have to build a better way for us to communicate with our customers, which I'll now be able to do, which is nice, right? Because we'll actually have a server infrastructure up so I can start to do things to replace these ridiculously crappy services that suck and can't even do basic things like send text back and forth. But it's like that's, I need a way to bootstrap that process and, I need to somehow, right? I need to be able to communicate with our customers up until the point where you can actually create a better conduit. So I don't know. But I'll look at that DMARC thing because maybe that is part of it. I don't know, like, that was not something you could do back when we set this up originally. So maybe we need to set that up, right? And we'll see. I'll have to look. I can log into the SparkPost thing now and see if it's there. So I don't see anything about DMARC here, so maybe I'll have to go read up about it. I don't see anything about that. Like, it does, it's got the stuff about like adding CNAME records in the text records, but I don't see anything on here about DMARC, so I'll have to go read up on what that is. SendGrid, huh? I'll look at them as well because we're not having any luck with SparkPost, so I'll have to look and see if I can find another option. Thanks for the tips though, because I really want to get this straightened out at least to a certain degree. So we'll see. All right, folks. So I think we're basically at time here. I said it was till 9, and it is 9. Thanks for hanging out. Hopefully some of those question answers were useful. And thanks for the suggestions about the spam stuff, because I need something to try. We can't really keep going the way we're going because we can't even send mail to our own mailing list, which is kind of ridiculous. Um, so I would like to at least try to get it a little bit better. And so I can try the SendGrid stuff, and I'll just try it, right? I'll just try and see, does we get it? If it's better, it's better. But at least it gives me something proactive I can do, whereas right now, there's nothing proactive for me to do, which is a frustrating feeling. I have my own mail server, but Thunderbird put it in spam. There you go. Thanks, Thunderbird. All of this stuff has to get rebuilt. Guys, it has to. I mean, think about how simple this problem is. If instead of signing up for a mailing list, you just put into your email program the email address that you were trying to subscribe to, none of this would be a problem. Right? Because it would be pull instead of push. So, like, RSS is the right solution to this problem, or something similar, right? And they were just like, no. Like, that's just, no, we can't do that. We have to do this ridiculous, stupid idea. Yeah, I mean, RSS wasn't perfect. I wouldn't use that term, but at least it's reliable. Like, you know that anybody who wanted to get your mailing list will get it if RSS was still a thing. Now, nobody uses RSS. Nobody even knows what it is. So you can't really operate a mailing list using RSS because you would have like 6 customers, the 6 people who still remember how to use RSS, right? But that was the correct answer. You should have just had a thing on your inbox just said add feed, and they would just show up as mails. Right? I mean, how hard would that have been? But no. Anyway, thank you very much, everyone, for joining me. Yeah, it was fun answering questions. It was not so fun talking about the spam thing because that always upsets me every time I find that out. But semi-damn idea, you could set up a newsletter on Substack. So that's not a dumb idea. I mean, I would be fine setting up a newsletter on Substack. So, that's not a dumb idea. You said it, you called it a dumb idea? Well, you called it a semi-dumb idea, so I think you knew there was at least some smartness in there. You knew it. Because then it's like, okay, it's coming from Substack. If they start sending Substack to spam, then, like, people who paid for this newsletter are not going to get it or whatever, right? Because, like, there's a bunch of people who charge for their newsletters on Substack. So in theory, if you start a newsletter on Substack that's not paid, it's just free, which as far as I know you can do. You might be able to just kind of like ride those coattails, right? It's like, yeah, we're just using this as our company's mailing list. Unfortunately, I can't import our existing mailing list to Substack. At least I don't think you can. But, I could try to communicate with our customers that if they are having trouble getting delivery of our email because the people at Google learned to program from a toll-free number they got in a Cracker Jack box, maybe that's like just another option. I just I send the newsletter out via SendGrid or something, and maybe it gets some people, maybe it doesn't. And then if people have been having trouble getting the newsletter delivered to them, they know that they can go to Substack and subscribe there and have a better chance of getting it. Not a bad idea. Not a bad idea. I could see giving that a shot. I mean, what do I have to lose, right? I copy the email over to Substack. Right? So, like, that seems pretty good. That seems actually pretty good. Thank you for that semi-dumb idea, which I'm going to have to say is not semi-dumb at all. So, I'm going to go think about that. That's what I'm going to do as soon as I close this stream. So thank you. That was great. That's a very good idea. I'm sorry. It's a semi-dumb idea, according to you. But according to me, it's actually a pretty good idea. All right, everybody. Thanks for joining me. We'll have some more stuff to talk about, I think, during the Meow the Infinite Kickstarter. We're trying to do a couple other things for promotional stuff for sure. But for the most part, it'll be a normal weekend. I'll be back here on Sunday to do Handmade Heroes. So there'll be that as well. I'm going to go see if I can figure out about that Substack thing, because that's actually a pretty good idea. That's a way that they can't really screw you quite the way that they currently are, because now you've got a lot more angry people if they start to block that email address. So that's not a bad idea. I might give that a shot. Thanks for the suggestions. I will report back if I try that maybe on Sunday during Handmade here. I'll give a little postmortem on how that went if I give it a shot. All right. Thanks, everybody. I'll see you guys on Sunday. Until then, have fun programming, and I'll see you on the internet. Take it easy, everybody.